So hello everyone. Welcome to this webinar on data warehousing trends, best practices and future outlook. I hope you all are doing fine and staying safe. I'm Parag, your today's host and moderator for this session. I work as a product marketing manager at Heve. So let me introduce you to our today's speaker, James Serra, who is a data platform architecture lead at Ernst & Young. Welcome, James, and thanks for joining us today.
Yeah, sure. Happy to be here.
Great. So before we start the session, just an important note for everyone. So all attendees will be on listen-only mode. We are going to record this session and going to send you the recording post this session. If you have any questions during this session on any of the slides, then just type in your questions in the Q&A window available on your screen, and we would be happy to take those questions at the end of the session. All right, so here is the agenda for today's session. I'll just do the introduction part. Then we will have a presentation, detailed presentation by James. Then and in the end, we'll do a Q&A round. Cool. So let me quickly introduce you to Heve for those who don't know about the platform or the kind of offerings that we have. So we so before we jump into the introduction of Heve, so we all know, I mean, we all deal with a lot of data silos, and we know integrating data silos is a tedious and time-consuming task. Engineers spend a lot of time writing scripts, custom code to integrate their data from multiple sources, clean it, and make it analytics ready. That's where Heve comes into picture. So Heve is a no-code data pipeline platform that helps you integrate your data spread across multiple sources into a data warehouse of your choice. It can be Redshift, Snowflake, BigQuery, and many more that are available in the market. So the platform provides 100 plus pre-built integrations with different types of sources, including databases, data warehouses, streaming applications, SDK, SaaS applications, and many more. So you can easily connect your data sources and unify your data using Heve in just a matter of few minutes. If you are not using any data warehouse, in that case, Heve has a solution for you. Heve will help you set up your fully managed data warehouse in just a few minutes. Now, once you have all your data in the data warehouse, you can easily plug that data into any BI tool or any business application of your choice for detailed analysis, reporting, and decision making. Heve supports multiple use cases, and it's a feature-rich product that provides preload, post-load transformations, data modeling, data pipelining, auto schema mapping, and many other features. And there are thousands of data professionals across 26 different countries are using Heve to solve their complex data challenges with this unified data that Heve provides. So if you want to know more about the product or the entire platform, then please check our website, www.hevedata.com. You can sign up for a free trial there, or you can even ask for a demo with our product expert. Cool. So let me quickly introduce you to our today's speaker, James. James is an expert in data warehousing and data management space. He has over 35 years of experience in data modeling, data governance, and development methodologies, and holds the Microsoft SQL Server MVP title. James is currently working as a data platform architecture lead, director in the client technology group at EY. Prior to EY, he was working at Microsoft as a big data and data warehousing solution architect for almost 7 years. Prior to that, he worked as an independent consultant for data warehouse business intelligence projects. So with this introduction, I will now request James to take over the control and start with the presentation. Over to you, James.
All right, great. Thanks. Great introduction. 35 years. I can go all the way back to COBOL. If anybody wants to have a conversation about that, that's how long I've been in there. So I'm having trouble. It says disabled screen sharing. You got to turn something on.
Let me check. Now you will be able to share.
All right, cool. So let me pop up share. And there you go. You can see it now?
Yes, I can.
All right, awesome. So welcome everyone. This was already covered in there. So the agenda for today is I'm going to talk a little bit about why you want to have a data warehouse. I'll talk about data warehouse. What does that mean compared to a data mart? A little bit about the Kimball versus Inmon, that sort of controversy that's been around forever, and explain what exactly you mean by Kimball and the Inmon architecture. I'll touch on a little bit about the data vault, and then I'll go into the data lake, and then proceed to talk about why databases fail, why they succeed, and then ended up with some new concepts you may have heard about. I've been blogging a lot about these lately. Modern data warehouse, what does it mean to have a data fabric? And what is a data lakehouse, and then data mesh on that. So we'll take some questions at the end, and happy to have follow-up questions on email. You see it right there. So feel free to reach out to me. So getting started, if you're trying to build your data warehouse on your own, you may end up like this guy. It's not an easy endeavor. And there are tools like Heve and such to help speed along the process, but you need to have a good understanding of what's involved, the time commitments to it, the technologies, the concepts. And that's what I'm going to try to start you off today, is prevent this from happening. What a data warehouse is not, and being in the industry so long, I've seen sometimes comical of people's interpretations of what a data warehouse is. One of them being, it's not a copy of the source database with prefix DW attached to all the tables. I've seen that in a few cases. That's a database is not just copying all these various source systems and putting them together in a view. I've seen that over the years, and it's just not a dumping ground for various tables and calling it a data warehouse. And that happens a lot when customers decide that somebody wants a copy of the data and they want to do some querying off of it and not mess with the source system, and they dump it into some, what they call a warehouse, and thinking it's a temporary thing, and then it grows and it grows and eventually becomes their data warehouse, but there was no design up front, and it becomes a nightmare in there. So don't follow any of these patterns, please. So what is a data warehouse and why use one? Well, it's a way to collect all this data from various source systems to get better insights into your company and make better business decisions. That's what it comes down to. It's not an OLTP application, but rather a collection of the data from OLTP applications within a central storage in there. So by copying the data over, you reduce stress on the production system. I have many stories where people were running queries against source systems and brought them down because these queries were long-running queries. Well, the first thing you want to do is copy that data over into a data warehouse, so you reduce stress on the production system. You can optimize it for those queries. You can integrate many sources of data on there. So I can pull data, customer data, say from ERP or CRM systems, and combine it with data of about the various geographies that people live in, and it just goes on and on. So you integrate all those sources of data, again, to make those better business decisions on there. It's a way to keep historical records. Many times I've seen customers just create these monthly reports and put them out in folders. Well, no longer have to do that. With a proper data warehouse, you can always go back in time and view reports without having to create any files or hard copies up there. It's a great way to rename tables and fields. If you're familiar with ERP systems, they can leave a lot to be desired in the way they name the tables with numbers and such. So by creating a data warehouse, you rename those tables and fields, and you make it much easier for people to query off them because they understand them a lot better. It also protects against source system upgrades. So if you're running queries against a source system and doing reporting, and then the source system changes, those queries could break. So a data warehouse prevents that from happening. It buffers that. You can do things like master data management and hierarchies within a data warehouse. You get that additional functionality. You can get to the point where it's self-service BI and self-service reporting, and the end user can query off that data warehouse and build reports and dashboards very easily because of the effort that went into building a data warehouse. And so IT is no longer the buffer, I'll call them the bottleneck for generating reports. And can also improve data quality, because a lot of times when you build data warehouse, you'll notice problems with the data. And those can be then brought to the attention of the front end OLTP applications to correct those. And then in the end, you get one version of the truth instead of everybody having different opinions or copies of the data and therefore different versions of the truth. And then it becomes very easy to build BI type solutions on top of that using products like Azure Analysis Services. So you can get additional reporting and slicing and dicing of the data. Without an enterprise data warehouse, this is what it looks like on the left. If you just try to query, you're going to have a lot of complexity and crazy queries to get all this data and join it together. Enterprise data warehouse gives you that nice picture on the right where you can copy all this data into some single version of the truth and then run reports off of that. And so you'll greatly speed up your time to build reports, and then you can get insights and slice and dice the data in ways you can never do before. When you look at in my 7 years at Microsoft, I spent a lot of time in front of customers having discussions about what they built for data warehouse wise. And I found these 4 different stages, and most customers are just in stage 2 where they're trying to collect all this data and centralize it, usually in the cloud. The idea is to do digital transformation where you're moving along these stages, and instead of just looking in the past, the rearview mirror, you're able to do predictive analytics and use machine learning and things like that to predict things in the future and take action on things to prevent or improve those instead of just seeing trends from the past. And in the end, the idea is to create a solution that can use data, no matter what the size or the speed of the type of the data. And that's what you'll get by building a proper modern data warehouse. Now we look at a data warehouse for Data Mart, and just to level set, think of a data warehouse that has all the data in a company, many different subject areas. A data mart becomes a subset of the data warehouse. So after I build this nice data warehouse, and I may have finance says, we want a copy of the data, and we want our own copy because maybe for performance reasons, or maybe they want to do more things with the data to transform it, you can create these subsets of the data for those particular subject areas on that. And so think of it in short as the data warehouse has all the subject areas, data mart is specific to those subject areas. Now what's interesting, and I got to bring up here, is this data mesh concept. Sounds a lot like the data mart. And since I've been around so long, this is the trend you start to see happen. People just come up with different names that sound more impressive in a way for technology or concepts that's been around. So while data mesh has some additional functionality and ideally some benefits to it, in some ways it's a lot like the concept of a data mart. And we'll talk at the end about the data mesh. Now, you may have heard Kimball versus Inmon. What's the difference between these two? And I put these pictures of fighting because I remember at least a dozen years ago, it was very contentious of which data model I should use when I'm building a data warehouse. Now, this was also before data lakes came around. So they've changed things. And I'll talk through these methodologies without the data lake and then touch on the data lake on there. And so if we dig into these, you may have heard a lot of what I call myths over the years about these 2 different approaches, because in the end, they're pretty similar, and you're going to use a combination of the 2. It's not one versus the other anymore. And the idea that Kimball's this bottom-up approach without a focus is just not true. If you ever read Kimball's book, it's awesome, and it still applies a lot today. And he talks about this bus matrix, conform dimensions, and mastering data on that. So he has the idea of you're going to create this major plan and then build it out in pieces on there. But it's not a solution that doesn't look at the overall picture of an enterprise. Inmon always has this myth that it requires a ton of upfront design and it's got this waterfall approach, which is not true. It's pointed out in his book. It's not this big bang approach. So don't think of it as I don't want to use it because you have to do with design up front. It's not true. And then Kimball, you see, talks a lot about the star schema. He sort of invented star schemas. And the myth is that Inmon model doesn't want you to use star schemas. It's not true. He says that in one of his books and a lot of his papers now. And they've all adjusted their models over the last few years to account for data lakes too. And then the other myth is that nobody uses the Inmon method when, in fact, I've found more people, and this was a study done a few years ago, use the Inmon method, but it's not, nobody uses the classic Inmon and classic Kimball in there. You can kind of say, if you have an enterprise data warehouse, you're more focused on the Inmon model, so you fall into that category. And then the idea that they're incompatible is not true at all, and I'll cover that. At a high level, think of Inmon is focused a lot on a relational database, and Kimball is focused a lot on the dimensional database on there. Relational modeling is what's been around forever. It's third normal form. It has normalization rules, part of it. It's a lot of joining of tables together, and you have these history tables, natural keys, and it could be a very good solution, relational modeling, for accessing the data on that. You could run into problems with performance and the complexity, and that's where the dimensional model or star schema comes into place, where the idea is you're using facts and dimensions, and you're denormalizing the data, and it makes it much easier for end users to query the data because they're not having to understand how all these tables join together. And also you can get performance benefits because you've optimized it in the star schema and reduced the joins. There is more upfront work because you're gonna have to go from third normal form into a star schema, but the benefits of that are tremendous. You see star schemas are extremely popular. If you use products like Power BI, it's sort of built to use star schemas in there. And so it's a great solution. If we look at this as far as what the model looks like, this would be a relational model on the left, dimensional models on the right. So if I'm an end user and I need to build a report and I'm using just a relational model, there's a lot of complexity in there I have to figure out. And there's always one person at an org who understands everything fits together, and you have to always go to that person on there. And so dimensional models will take that away and make more self-service BI by combining into these sales and facts and dimensional tables where whatever tool you're using, like Power BI on top of that, it knows the relationships and it knows how to join all the data, and you don't have to worry about that. So if we look at Kimball, he'll talk about a logical data warehouse. This is a combination of the data marts to make a bigger enterprise data warehouse, but it's all in logical in his approach on there. And it's a lot of business driven. You want to have the users have active participation in his. The idea is the data marts are decentralized, meaning they don't have to be separate physical data stores. They could be all logically put together. And they're optimized for reporting. You'll hear things like conform dimensions and integrated dimensions and stars and solid chain dimensions. There's a lot of concepts in there that make it easier to query the data and track history of the data. And think of it, if you have a data mart in a cube, so there's less ETL and less data duplication on there, because there is no third normal form. You're bypassing that piece of that. Where in Inmon, he has that enterprise data warehouse, so it's an extra piece to it. He touts that it's more IT driven, but definitely you want to still have user passive partition. And there's a fine balance between those two. They'll have these normalized tables that are in the end off limits to the end users, and you'll create the dependent data marts that's what the end user will use to query the data. And so he has this 3-tier where you have the data warehouse and data mart, and then these cubes built on top of that. So you have more duplication of the data. And the cubes, if you're not familiar, is just a way to aggregate the data and put it in a format that makes it very easy, very quickly to query the data because it's been aggregated. So you do this upfront work where you process a cube, and then it has all combinations of the way that it thinks the data will be queried and joined. And then when you use the cube, you get that millisecond response time. If we look at the Kimball model at a high level, we have your data sources, they go into the staging area. And then from the staging area, it's created these star schemas, these data marts. From those star schemas, you can certainly report off data in there. You can also go one step further and create cubes. This is a little dated. Most cubes now are tabular model on there. And then even old school, I'm using SSIS, but you can use a lot of products instead of that, like Azure Data Factory or when you look at the Heve, that they have the same idea of using different ETL tools. The Inmon model looks like this. You'll see it's got the staging area, but then it's got this data warehouse where the data lands in third normal form. And then you can copy the data out to data marts, which are third normal form, but a subset of the data. And then you can build the cubes on top of that. Now, when you look at this picture and you have this enterprise data warehouse, or you call it the corporate information factory on there, why would you want that? Well, there's a lot of reasons that instead of having individual data marts is, when did you get a single version of the truth? Because having a lot of data marts can cause problems because each data mart can have multiple copies of the data on their curve. And so it can sometimes cause a lot of problems. It creates these lightly denormalized tables instead of going directly to OLTP source in there. So once you copy it into the enterprise data warehouse, you never have to go to OLTP source, where in Inmon is, if you have to go back, there is no central source, so you have to go back to the original OLTP source. It makes it easier to spawn off data marts because the data is all collected in one spot. Again, not at the source system. So if you're okay with duplicating data, you can quickly create all sorts of data marts. And then there's less ETL refresh if the reconciliation of that is happening from multiple databases, which happens in the Inmon methodology on there. And then there's one place to control data. So if it's all in an enterprise data warehouse, again, you don't have to repeat the process of updating all the data marts what you have in the Inmon solution in there. And then it may be, well, I only have a few sources and I don't really need an enterprise data warehouse. It's not worth the effort. So that's that balance you got to look at. But beware that usually a data warehouse may only start with a couple of data sources, but it quickly expands to a lot more. So always keep that in mind. So which model to use? And they've become very similar over the years. If you read the books years ago, they've over time added new features to their models, which made them very complement each other. And in the end, it's simple. Inmon has a normalized data warehouse before creating the data marts, and Kimball skips that part. And then, but with tweaks to each model, they can wind up looking very similar in there. And in the end, you use the approach as what's going to work better for your situation, because there is no standard solution for everything. A lot depends on your data, the size, the speed, and the type of that, of which solution will work best for you. And it also comes down to, you have to have the soft skills. You have to have good communication, good talent that is going to build this out, or else whatever technology you use is going to fail. So a key part of that is getting that proper team in place. And so a hybrid model will look like this. In the end, it's that enterprise data warehouse piece that is added in addition. If you look at the Kimball model, we add that into it. So in the end, yeah, there's more layers to this and more complexity, but you're coming up with more ways to query the data that are easier for the end users. And so that's how you want to think about it, is that a lot of times that upfront effort is worth it. And I also wanted to point out the Kimball methodology is more than just how to model data, which Inmon is just about the modeling data. Kimball goes a lot more into other aspects of gathering the business requirements and project management and such. So his book, the Microsoft Data Warehouse Toolkit, was kind of the standard Bible for many years, and really still is, because most of that still applies. It's just the technology has changed, but the concepts are still there. And then I briefly touched on the data vault. This has been around for a long time. And I rarely see customers using this, even though I think it's a great solution and definitely has its use cases, but it just hasn't gone on big time. And so if you say one negative thing about it is, well, not a lot of people are using it, so it's hard to find skill sets of people in there. But it adds a couple of extra layers in between the Kimball model. So if you look at this picture, it adds this thing called hubs and links, and then satellites, which are kind of dimensions. So it really helps if you need to do a lot of auditing and historical tracking, much more than it comes into play with what you would do with the Kimball method on there. So definitely want to look into this and be aware of it, because you may run into a case where your Kimball model is just getting too complex because of all the historical tracking you have to do, and a data vault may be more make things a little easier for you. And there's a great link I put on here, and we'll share this deck that talks more in detail about the data vault. So jumping to the data lake concept, the idea with a data warehouse only that is it's top down. I have to model it and do a lot of work up front. I have to kind of know ahead of time what questions to ask, and then I can query it. If we look at what came out about 10 years ago with the data lake, is it's a great way to investigate the data, and maybe you're not even sure what questions to even ask. You need to experiment and go through this data and see if it's got some value out of it, and then you can start using it. The benefit of a data lake, it's just a glorified file folder. I can dump data in there, and the tools now make it very easy to query that data, even with T-SQL. And I can see if this data has value, and I can even do quick reports. I can even do machine learning on it, and that's this bottom-up approach. And the top-down approach is great for historical views, and the bottoms-up is great for doing some predictive analytics, building some machine learning models on it. And what's happened is with the data warehouse using a top-down approach, where I gather the requirements, I build out everything, and then I get the data warehouse. And that can take a lot of time and a lot of effort in there. Where the data lake approach is, I can quickly dump all sorts of data. It could be even streaming data into that data lake, and I can run queries on that. But they were very two distinct systems. They both had their pros and cons. And when people tried to build a data lake up front and not use a relational database, that failed miserably on there, because there are a lot of benefits you get from a relational database that are not part of the data lake. So the best idea is always to combine the two and have data that's copied in the data lake, all the data in the data lake, and then some of that data copied to a relational database. And so you can then easily have the best of both worlds. And the products today have gone a long ways into combining these different philosophies into one. And you could say, well, I don't really get a data lake. Why do we need one? Well, a lot of reasons. And this slide, I remember years ago, started out with a few and just kept going. And I'll just touch on a couple here in bold that are reasons, major reasons to have a data lake in there. One is a schema on read. So I can copy data in there. I don't have to model it. I can quickly query the data and get value out of it without that upfront work. If you're using just a data warehouse, you're copying data into there and then you're cleaning it inside the data warehouse. Well, the problem with that is then you usually have to have maintenance window. You knock people off, you do your cleaning of the data, and then you allow them on there because you're using the compute of that data warehouse. If I put the data instead into a data lake, think of it as moving the staging error from a relational database into the data lake, and I can clean it there, and I'm not affecting people who are trying to run queries on that relational database in there. And so once I clean all the data, I can move it into there very quickly. And so the maintenance window goes from what could be hours to just a couple of minutes. And you can also add a lot more compute because the data lake is just storage. And on top of that, I can put all sorts of compute, even massive amounts of compute if I'm willing to spend the money and clean that data very quickly, much quicker than it would be in a data warehouse, a relational data warehouse. Having a data lake means that for power users who can get to the point where they can understand how to query data that's sitting in folders and doesn't have any metadata along with it, they can generate reports and do machine learning on top of that. So you can get very quick returns on your data by using a data lake and focusing on just querying it within the data lake. The other thing I see a lot of customers using is when the data is put in the data lake, I can go and explore the data and see if it's got value before I go through the effort of putting it in a relational database. And I was a DBA for a dozen years. I can't tell you how many times an end user said, oh, I need to put this data in a data warehouse. It's really valuable. And I go and I create the table and the fields and I write the ETL and I put it and I finish it. And then sometimes it could take days or weeks. And then I tell the end user, okay, the data is ready for you. And they look at it and they go, actually, this data is not helpful. You can delete it. And I was like, I would spend all this time up front. If I could put it in a data lake and you have a power user who can query it, I can go, hey, look, go and see if the data is valuable. It's out there in the data lake. It only took me a few minutes. And if it's then valuable, I can move it to a relational database. Or maybe you just need a one-time report. So instead of going through all that effort, dump it in the data lake and run the report and you're done with the data. And then having this extra performance, I touch on this to run compute options onside that data lake is tremendous, especially when you get IoT data and you can't wait till the end of the day to run compute. You want to do it as it's coming in there, and you want to have maybe pull up some massive clusters of CPU that can query, that can clean that data. You have that with the data lake. So when we look at the two at a high level, you can say, think of a data lake as that staging and prepping area, and think of a data warehouse as your serving and security and compliance layer in there. And so now you get that best of both worlds in there. And so if you look at, well, what are the challenges of just going with a data lake? You can point out, and I have a lot of blogs on this, things like security on there. Data warehouse has a lot more security, row level, com level, all these other things in there. And so a lot of customers will say, I'm just going to cut off the data lake to all but a handful of people because I don't have some of that security that I need, like row level, and I'm going to instead let people use a data warehouse, and they may be used to a relational model, and that could be the serving and security layer in there. And so by having the best of both worlds on here, you can support all types of people and all types of concurrency and all types of queries on that. So that's why I highly recommend having both a data lake and a data warehouse. It's set to some very specific use cases, and the tool sets have been improving. So when we get into the data lakehouse concept of just going in a data lakehouse, okay, maybe, and in the future, maybe more of that. But for now, in most cases, you're going to want to still have a relational database. Okay, why did database fail? And Gartner had said the 70 to 80% fail. And I don't know about their definition of fail. It could be that it doesn't work as expected right away and it's a later fix. That number does seem high, but that's what they tout. And through my career, I see some of the reasons why data warehouses failed is you always have that one executive, it seems, who thinks, oh, this is easy to implement, and I'm going to just assign a few resources and in no time I'll have a data warehouse. Or I've had where I create a POC and I show the executive and they goes, oh, this is great. How long? And I say, he asks, how long is it going to take? And I'll tell him it's going to take months. And he goes, well, it looks like it's already done. I was like, no, it's just a POC. And so you have to get people out of that mindset on there. Or if they do things like start with the end date and work backwards, there's always a recipe for failure on there. And they then start shortcutting the process, especially data governance, in order to meet that end date. The lack of human involvement is a big one. You always want to get those end users who are going to be using the reports involved early in the process, so they feel like they have some skin in the game. They're not initially hesitant to see the results because they haven't had involvement in there. So definitely get them involved in business requirements when you're doing POCs, as you're moving along. Check in with them, show them what you've done, get their involvement early, especially for clarifying the accuracy of data. I've seen customers have both ends of the spectrum with almost no business requirements to spending months doing business requirements on there. And that's always a recipe for disaster when you're too one-sided on there. The same kind of thing, they have too much design or not enough. So they get the business requirements and they over-design it. Because a lot of it is that you think things are going to work and then they don't work like expected. So you have to be willing to change in there. And so you don't want to spend up a lot of front architectural design if it's going to wind up changing anyways. Data governance is always the big one. People always underestimate the time it's going to take for data governance. I always hear from the end users or of the source systems, the people who run those source systems think their data is clean. And I always have a running bet that I guarantee you I'm going to find problems with data in there and have to clean it in there. And sure enough, you always find that. And so you have to put a lot of time in your project plan for cleaning the data and mastering it and securing it and all those things. And then a lot of it is choosing the wrong technology. Customers, when at Microsoft, they don't know what they don't know. So they come in and they think, I'll use this product for everything. And then you need to educate them and say, well, according to your case, there's other products that may be better, and they may not be aware of those products. And then how many, sometimes tens of millions of dollars is spent by choosing the wrong technology. So spend a lot of time up front investigating all your options, and then make sure your use case matches the products that you choose. Other reasons, communication is a big one. Shutting out the end users in there, don't communicate with enough. You got to have a lot of other communication in there. Not validating numbers. The worst thing you want to do is generate that first report, and end user looks at it and goes, whoa, this is not accurate. You've already lost your confidence, and there's no going back from that first impression in there. So spend a lot of time at the end of the project to validate the numbers and compare them to the previous reports if they exist, or go to the end user, kind of off the record and say, look, we're trying to validate these numbers, can you help me out? So you get that confidence once the reports are done in production. Slow response times, that's always a big one. And that's where you get a lot of times end users going, forget IT, I'm gonna go build my own solution because it's taken too long. And a lot of reasons for performance, but again, it comes down to creating a good architecture, knowing the different ways, hiring good DBA, and getting that ideal performance, squeezing it all out of data warehouse. Because it's very challenging when you start getting into many terabytes or petabytes of data. Inexperienced, lack of technologists, so just hire good people or get consulting companies to come in to help you out. And then the modeling becomes too much focused on the way it looked in the source data. You've got to completely rethink it and put it in a data warehouse type of solution that's going to be very different from the source system on that. So now you need to hire some good data modelers. Wrong consulting company hired is, oh, I have a lot of good experience and stories in this on that. And so spend time up front, making sure you vet, if you're going to hire somebody, which I usually recommend, unless you've built data warehouse before, and make sure they have the experience. Offshore development can be a huge problem unless the requirements are very specific. The consulting company can come in and own the whole project, which could be challenging because you're out of the loop of what's going on, and you're not seeing problem areas that they're having. And then in the end, no matter what consulting company you have, make sure there's knowledge transfer or mentoring along the way, so your company can pick up where they left off and not have to rely on that consulting company all the time. And then the budget runs out because you didn't think of enough time that's going to be spent in getting testing and DBAs and program managers, or the cloud costs, software licensing, training. Sometimes they don't even think about adding training to it because all the end users are now going to use a different system. So you got to train them all. And so they fail a lot of times when there's no more money left on there. So that's where upfront project planning and budgeting is so important. Why they succeed? Well, everything I just talked about making fail, avoid those. And then these other key points on here, choosing the right technology. Spend a lot of time up front on that again. Understanding Kimball, Inmon, star schema, relational, modern data warehouse, data fabric, data lakehouse, data mesh, a lot of concepts. I'll touch on a little bit later, some of them in there, but understand what all these mean. And don't just latch on to the latest thing and say, oh, this sounds great. Because it may sound great in theory, but in practicality, it may not be appropriate for what you're building. Find a project champion, somebody within your company, higher level person who's really going to sponsor it. And that will be the person that can push for higher budget, they can, and more people to jump on there, and they can also coordinate any arguments or problems that you may see from end users as you're building the solution. So look for that. Hiring a director who keeps running at it depends on efficiency. I've seen over the years so many times the people in charge, project managers and above, just not laying out the project plan and having too many things outside of the project. It could be these meetings or training or all these things that you're not going to get somebody running 100% efficiently, but there's a lot of things your managers and above can do to keep you working and not get off sidetracked with things. And that's one way projects, data warehouses projects fail, is too many people not focusing on what's important. And then you want to have an agile approach. There's many different agile strategies out there. Pick one and use it, and break your project into phases. And you're going to get so much more benefit than the traditional water flow approach, or just kind of swinging it by your pants. It's either your pants on there. And the best part that comes out of something like what agile approach is quick wins. You can go in there and just maybe after a few weeks show the end user, look what we've created, and then get them excited about that, and maybe unlock some budget and get more additional resources on that. So definitely break it out and use an agile approach to it. And then I found you can also get people excited about what you're building in a data warehouse through training. The idea being they can get a early glimpse of what the art of the possible is. Because if you go to end users and say they're using Excel, and that's been their livelihood, and they don't know anything about Power BI, you tell them, hey, we're going to train you into Power BI because that's what we're using. And then they see the art of the possible with Power BI, and you can see their eyes light up. Well, I never knew I could do this with reporting. And they love the reports and the dashboards and the slicing and dicing of that. So I found training to be really helpful in getting people excited. Do the training at the appropriate time. Don't do it 6 months before you're going to roll it out, but maybe a month, or maybe some very early training. Just if you need to get them excited early on in the process, training is the way to do that. Power BI now is a very powerful tool. It can be used to quickly prototype. So I've seen a lot of customers where they say, instead of going to the end user and getting business requirements, they train them in Power BI and they tell them, go and prototype what you want. And then they prototype it, and then you have a great picture of what they need, and there's no longer going back and creating something for them based on their business requirements, and they go, oh, that's not what I meant, or I forgot to tell you this thing. The prototyping can be really helpful when the end users are doing it, and Power BI can definitely allow that to accomplish that. All right, so I wanted to talk a little bit about those concepts that you see a lot of talk lately on some of these concepts on there. And then I'll have a number of minutes, maybe 10 minutes to take some questions. So we look at the modern data warehouse, and I usually whiteboard this out. That's why I copy my whiteboard. The idea is we have these 5 stages. All modern data warehouses basically operate the same no matter what technology you use. You have to ingest the data from multiple sources. That's step 1. You need to store that data somewhere. That becomes your data lake. And usually you have multiple layers in the data lake. The raw layer, source system as it is, and then I clean it, and which is step 3, the transformation of that. And I put that in another layer. And then I may do more to that. I may join the data, master it, do such things to create a presentation layer. And then I also may have a sandbox layer. Maybe a data scientist just wants a copy of the data. So the data lake design is very important. And I spend sometimes the whole day with customers on that and there. So make sure you think through that early on, the way that's going to be, because also within each layer, then there's a folder structure. How am I going to do that for performance and security reasons? Do I do it by subject, by date? It's usually a combination of those things. And then you want to model data. So as I mentioned before, the data lake is great. I have that end user in the hat who can go and query that data right away. But most of the times it's too much for your average end user who doesn't understand the technology enough to create reports off of data in the data lake. So you have instead a model of the data where you move it over into that relational database. And then step 5, you have that visualization where that end user it doesn't have a hat. That's how I differentiate the two, non-power user. He or she can go in there and say, oh, this is great. I can just go to a dashboard and just drag fields, or a workspace and drag fields and create a dashboard on that, because the upfront work has been done. And so that may be, I move into a third normal form and then I start scheming within a relational database. Now I put technologies on here, but the concepts remain the same, whether you're using, what I put here is Azure technologies, or whether you have database automation tools as we discussed here on top of that, or Amazon or Google. It's just replacing what's in green with different technologies in there, but those concepts will remain consistent. So if I go from a modern data warehouse, what does a data fabric mean? And really, I think of a data fabric as a glorified modern data warehouse. Now, this is not a industry standard way of looking at this, is my opinion. Others share it, but happy to have conversations or even arguments over what does it mean to be a data fabric. But in my interpretation, it means I'm taking a modern data warehouse and I'm adding a lot of components on top of that. Things like data access and policies and a data catalog and mastering the data and virtualization and possibly in data science tools, APIs to access the data. And then you break things out into building blocks and products, which is something we're doing at EY and building this very large data fabric on here. So that to me is what a data fabric is compared to a data warehouse. Okay, what does it mean by a data lakehouse? If we look back in my COBOL days, we had data warehouses on that. That's nothing new. We had data marts that were part of that. These have been around forever. And that worked great for many years. But then when the data became larger pieces of data, and you had data that was streaming on IoT devices and such, the data lake concept came around. And this is where that concept almost went too far in that end users were using the data lake and not using a relational database. And projects that were part of that didn't succeed. But the data lake had very great use cases on it when you just needed to do machine learning off of that. And then when they realized you needed to have both the data lake and data warehouse, that's where in the mid 2010s, the idea of combining the two, as I talked about, came in, where you have a data lake and a data warehouse. And now we shifted again to the idea that, well, maybe I can use the data lake as the sole repository and not use a relational database. And that's by putting features that are traditionally in a data warehouse on top of a data lake, hence the term data lakehouse. And this was brought on a lot by Databricks. And I will say, okay, it has more use cases now. So definitely look at, can I get away with just a data lake house and not a relational database? And when you look at products by Microsoft, like Synapse and the serverless piece, I can definitely see down the road more situations where you can just use a data lake and not have to use a relational database. But be aware of the trade-offs, and I've listed a lot of those in my blogs when you decide not to use a relational database. Data mesh, the term is new in the last couple of years in there, but the concept is very similar to data marts from years back. Maybe the biggest difference between data marts is the idea that all the other technologies, everything was centralized. You collect the data all in one space, where a data mesh is much different in that it's a decentralized approach. Instead of copying the data and collecting it in a central location, you're keeping it outside, and each domain, think of a finance, HR, operations, becomes the owner of that data as opposed to centralizing it and becomes IT's owner. And each domain has their own copy of the data that's kept there. So that's a decentralized approach. And adding to it is having a governance that's centralized, or maybe something like mastering the data is going to be centralized. But you're letting each of the domain owners have essentially IT-like people within their domains, and they are building their own solutions, but they are governed by what the IT team comes out to say, these are standards you should follow. This way, everybody's consistent in those standards. Everybody's following data governance, but the ownership remains with those domain teams. And so this is the part about it that I would say is different than data marts, is the ownership belongs to the teams, although you can argue data marts were like that too. And maybe the big difference though is the data mesh data is physically located all in these separate places. So the challenge then becomes, how do you query all that data that's all separate on that? And that's where some of the technology I think is not quite there yet. I had a blog today on this topic in there, so read that if you want, where I talk a little bit about this. But this is the concept of data mesh. And Zamek has created a book that's some chapters. So to me, it's exciting in its capabilities, but some of the challenges will be the technology, and think of data mesh as an organizational change more than anything. So outside of technology is the idea that the domain owners are in control of their own destiny and that aspect. Now, there are some issues with that I'm going to blog about in the future, because having been in the industry a long time, you know, sometimes the domain owners shouldn't be the owners of their data, or they don't have the skill sets to build out the proper solution, or they're thinking about just their own needs that are focused on their domain and not about the entire company. And so now you have the challenge of somebody needs to be the one that's going to say how we can combine all this data, and we need to make modifications to it at the domain level in order to join it all together. And so this is where some of the data mesh challenges come about. All right, that's it. And so I left 9 minutes or so for questions. I know that was a lot to cover, and happy to have some answers now, and then more can be sent as a follow-on to my email address, or you can look at my blog where I discuss some of these concepts in more detail.
Thanks a lot, James, for this insightful presentation. Now it's time for Q&A. If you have any questions, then just type them in the Q&A window available on your screen. And I'll be now reading out questions one by one. Here is the first one from Brendan. Is there a maturity model around governing decentralized data mesh?
It's and so read her book but now there's only a few chapters in the book, and then she's got some blogs that do go around governance, but this is where the technology, so there is things that work great in theory, but does the technology help? Is there enough technology for that? And so there's some of the limits of technology. Now, I've watched a lot of videos on the way companies are implementing, and the challenge I think is there's always exceptions to the data mesh. Oh, maybe we're centralizing the data, or we're centralizing data governance on that. And so I've not seen a consistent pattern across the two, and there's no data mesh in a box where you can just say this is the way we're going to govern the data on there. And then the technology is everybody uses different technology for this. So I think the short answer is I haven't seen a maturity model around data governance specific to the data mesh, but I don't know if you really need one, because data governance is data governance, whether the data is decentralized or not. So instead of centralizing it and putting governance on there, you're just telling all the domains to go and do their own data governance. And maybe you give them tools, but it's the same process, whether it's centralized or decentralized. How you clean the data, how you master the data, how you join the data. It's more about people and process than about technology.
Right. Here is the next one on the same lines. So here is a one from Rishikesh. Will not data mesh generate data silos?
Yes, it generates data silos. That's the whole point of data mesh, is you have all these siloed data. Now, you want to make them non-siloed by having access to them. And so data mesh has the idea of these contracts you create. And so you essentially have to agree that if we're going to data mesh and I want to be part of the mesh, I have to agree to these contracts. And those contracts say you have to allow people to query your data and do it according to this contract on there. So if you agree to the contract, you will be able to be joining the data mesh. The problem comes, and maybe this question is if some piece of data says, I don't want to do this contract, I want to do my things my own way. And then you have to say, well, you can't be part of the data mesh. Well, now you have siloed data. So do you make an exception to that? And so this is where I feel there is a bit of ambiguity in how we're going to handle a data mesh when you have domains. And this is a point that I will hit on a lot, is they're not always going to want to buy into what you're building on there. And how do you handle that? So that becomes more of that political problem than more of technology problem there. So it can lead to data silos if you don't get buy-in. And so now how do you get buy-in from everybody? Well, that's a whole other topic of what you're going to do to say, hey, a new concept, data mesh, and not just build it and they will come, but rather get everybody to agree. And so there's some good videos of companies you'll find out there that talk about their journey and the challenges they had to avoid data silos in there, but definitely a big concern.
Definitely. So here is the next one. So what is the ideal architecture that organizations should deploy to manage structured, unstructured, and semi-structured data?
Well, I was trying to read that one. I don't see that one.
It's in
it's
in the Q&A window. It's not in the chat.
Okay, sorry, I don't have that one. There we go. Much better. Okay, so what is that? Okay, so the idea is if you're trying to have data that's different types, structured, unstructured, semi-structured on there, this is where you have to have a data lake in order for it to handle the non-relational data, which is unstructured and semi-structured data in there. So having that data lake allows you to land all that type of data in there. So that's definitely a must. Then you can decide which of that data should be also copied into a relational database. Well, it's going to be easy to copy the structured data because it's already pretty close to the right format. The challenge will be taking some of that. Well, unstructured data, you can't do anything with it. You got to put some structure on it. So how are you going to do that? That's got to be decided. And then the semi-structured data, it could be like a CSV file where there's no metadata. So you got to figure out the metadata if it's not already in there. And then that could be moved into a relational database on there. But either way, even if you just stay with a data lake, you have to have the right metadata. And this is the challenge with the data lake is the data and the metadata are separate in most cases, unless you have CSV files that have got data inside of it or JSON files. But a lot of times you're going to find them separate. So how do you investigate the data? How do you keep track of it all if the metadata is somewhere separate? And that's the big challenge, because it's easy to bypass the metadata and go right to the data in a data lake on there. So I don't know if that answered the question, but have a data lake and have a relational database, and then spend time up front deciding how you're going to use all the data that comes in, because you need to investigate better what type of data it is, and then I'll guide you what solution you choose.
Cool. So here is the next one. What are the parameters that one should consider for building a data warehouse for near real-time applications?
Yeah, the real-time, and I didn't have a good question. If you looked at my modern data warehouse whiteboard, is that was, and I should have mentioned that was in a batch world. If I'm going to add real-time, you're going to get a little more complexity. You're going to have to use some tools up front in the ingestion phase on there. Now, if you're looking at Azure, that would be Azure Event Hub or IoT Hub and Azure Stream Analytics, or you can go the Kafka route. And it's a way to handle that data and queue it up. And the technology's come a long way in the last few years to be able to ingest data, even millions of events per second, into a data lake on there. So you want to look at tools that'll give you that real-time streaming, even tools within Microsoft like Data Explorer, where you can query billions of rows up front and in just a second or two, and immediately get some value. Maybe I want to see alerting. I want to set up alerting to see if there's some log that's saying device failed on there. So you can do a lot of that upfront analysis in real time with a tool like a Data Explorer on there. But in the end, you want to land some, but not all of that data from, say, an IoT device into the data lake on there. So investigate those tools for filtering the data and handling the alerting that you may need up front.
Cool. So here's the last one. So what's the future of cloud data platforms? So we have seen like the Lakehouse and the data mesh these are the two emerging technologies or platforms. But in your understanding, James, what could be the real future of cloud data platforms?
Mm-hmm. The relational database is always going to be there, and since the 80s, they said that we're going to go away, and it hasn't. And there's many reasons for that. So you can always have that relational data warehouse on there, because a lot of these technologies, which I said in my blog today, if you look at the data mesh, it could be a great solution, but for a very small percentage of companies, your company's got to be big enough to have these domains and this size of data. So I would say at least 90% of the companies, the data mesh is way overkill. Even a data lake in some cases could be skipped if you're a very small data set. But in the end, I think you always want a data lake and you always want a relational database, except in very few circumstances where you have so much data and so many subject areas that you may want to look at something like a data mesh. And a lot of it then comes down to how much money can you spend, what's your skill set. All those will determine what that architecture is going to look like. But if I were to say in summary, the future will be, we're going to have data lakes for the foreseeable future. We're going to have relational database warehouses for the foreseeable future. And we'll start to see spots where the data lakehouse and the data mesh are going to come and play. And I think those two will increase over time as the technology gets better and better. But they'll never overtake the idea to have a data lake and a relational database. Data warehouse, because even if you look at data lakehouse, it's still a data lake behind the scenes. And if you look at a data mesh, each of the domains are going to store data in a data lake and or a relational database. So that technology is still going to be there. And I'm waiting for something next year to come around that's going to challenge all this, because that's one thing I learned in technology in 35 years. Every few years, there's something new that comes around. Sometimes they stay, sometimes they go away, sometimes they challenge the current technology to take a new approach or add new features. And so it's not like the relational database has stood still and not done anything. As new types of data sources come into play, even products like SQL Server have adapted and handle different types of data that are streaming or JSON data and such in there. So they're going to adapt too. So that's going to be where maybe a use case comes along that could look good at a different approach if you're using relational database, but the relational database came with a new feature and I can continue using it.
Absolutely. Thank you, James, for answering all these questions. I would like to thank all the attendees for joining us today, and special thanks to James for sharing your valuable insights. If you have any questions or feedback about this webinar, then please write to me at parag, parag@hevodata.com. Cool, then I think that's about it for this session. See you at our next event. Till then, take care and stay safe.